This is a lesson for Chapter 2, Section 10, change expressed as a percent. So the first type of problem is just a regular old percent change problem. And so the way we end up dealing with these is we set up a little ratio, and the ratio goes this way: percent change equals, and then we take the amount of increase or decrease. So the amount of change, or we'll say amount of increase or decrease. So just the arrow going up means increase, arrow going down means decrease. And then we divide by the original amount. And then we go ahead and multiply that answer by 100, and that will give us the percent change. So let's take a look at our first problem. It says that the price of a truck is advertised as $19,900. After talking to the salesperson, Jack agreed to pay this much, a little bit less. So it's a percent decrease. What is the percent of decrease to the nearest percent? So we got to first of all find out what that decrease is. So we'll subtract the two numbers, so 19,900, and we're going to subtract 18,200. And once we do that, we have to figure out what is the original amount. Well, the original amount is the starting point. And so that is that 19,900, and that's what we're going to end up dividing by. And so we go ahead and do some work there. And so I'll pull up the calculator. And we'll do 19,900 minus, and we have 18,200. And that leaves us with 1,700, and we take that number and divide it by 19,900. And we'll go ahead and pull up that calculator once more. Let me try that one more time just to make sure I got that number right. 19,900. Oops. Erase that one more time. 19,900 minus, then I had 18,200. Okay, so 1,700 divided by 19,900, and that gives me this number here, 0.8 or 0.08, and then I had a 5. I saw it was the next number before it disappeared on me. And if I go ahead and change it to a percentage, I'd have to multiply this by 100. And when I do that, you notice how it's going to be 8.5%, but they wanted us to round to the nearest percent, so we'd say this is about 9%. Well, let's take a look at the next one. It says that these people purchased a house for this amount, they sold it for this amount. So this is the first amount that we had, this is the second, so we consider this the original amount. So first thing is subtract the two numbers. This is 475,000. We're going to take away 357,000. And then we're going to divide that answer by the original. So the original is not the biggest number, it's whatever we start with. And so when we go ahead and do that subtraction, we'll just do 475 minus 357. That gives us 118,000. And we're going to take that number and we're going to divide by 357,000. Now the nice thing is we have a bunch of zeros at the end that we can cancel out, so I'll just divide 118 by 357, and that gives us a number of about 33%. Let's check and make sure that decimal, that last decimal was a 0, so that is not going to affect the number. We'll round down, in this case 33%. So the next problem says find the percent error in each estimation and round to the nearest percent. So the percent error, so when we're talking about percent error, it's very similar to this last problem. We're trying to find the amount of change, and so the way we do that is we do the measured or estimated value, measured or the estimated, and we're subtracting from the actual. So we subtract those, but we take the absolute value. So it depends. It doesn't matter which one you start with. You just subtract the two numbers, take the difference. So if it's a negative number, don't worry about it. We're just trying to find the difference. And we always divide by like the original number before, but now we're going to just call it the actual number. So here it is. You estimate that a building is 20 meters tall. What's the percent error if the actual is 23? Well, you're just subtracting the two numbers, 20 minus 23. Again, that's just negative 3, but again, we don't care about the negative sign. We just want the absolute value, the difference. And we always divide by the original or actual number. And then once we do that, we've got to multiply by 100 to get the percentage form. So we'll times that answer by 100. So I'm going to go ahead and pull up the calculator. We see that 3 divided by 23 gives us this number, and multiply that by 100, and that gives us 13.04%. Well, that's not going to round that up, so we're just going to leave it as 13%. Was the error there. Here you estimate the salesman's 45 years old, but he's actually only 38. So we're going to take the difference of those two numbers, divide by the actual age, and when we do that difference, that makes 7 over 38, and then we're going to take that answer and multiply it by 100 to come up with the percent. So we'll go ahead and plug those numbers in the calculator, and we'll do 7 divided by 38, multiply that by 100, and it gives us 18.4. Still not enough to round up, so we're just going to say that's about 18%. Let's take a look at the next few problems we'll see. Here it asks us to find the measured dimensions of a rectangle are given to the nearest whole unit. That's what they have here. Find the minimum and maximum possible areas of each rectangle. And so when we're looking at this, they're saying that they're measured to the nearest whole unit. So that means that this could vary. A whole unit would end up being 1 unit. Well, 1 unit from either side, or actually, if I take 1 unit and divide it into two parts, I have 5/10. So I have 5/10 on either side. I've got that whole unit, like let's say this is 1 here. Well, on either side, I've got 5/10. So it's either 5/10 on one side or 1.5 on the other. And so I'm going to say that this 4 could either be 3.5 or it could end up being a 4.5. So 1 unit either side. Now 4.49 was actually what this should be, but since just for now, just to make it a little bit easier, I'm just going to call it 4.5. And this would end up being between 6.5 and 7.5. So it's going to be somewhere between these numbers. So we're going to find out the minimum possible area and the maximum. So we just take the minimum would end up being the product of the smaller numbers. So 3.5 times by 6.5. And so if we go ahead and plug those numbers in, 3 5/10 multiplied by 6 5/10, that gives us 22.75. This is the area of the figure if we had them the smallest area, and that's what it would end up being. It would be 22 75/100ths if we are rounding each dimension to the nearest whole unit. And so the maximum value would end up being between, if it was 4.5 to 7.5. And so when we go ahead and multiply those numbers, 4.5 times 7.5, it gives us 33.75. And this is centimeters squared. And so it's somewhere in this region. And the values that they used, again, were 4 and 7 because we rounded those two units to the nearest whole unit. And so this would be about the max, a little higher than the maximum, because typically if you have 4.5, I would round that to a 5, not a 4. But they're just saying about 1 unit of difference between those numbers. If you used 4.49 and 7.49, that would be it'd be pretty close to this number. So that is just a good approximation here. And the measured dimensions of a shape or solid are given to the nearest whole unit. Find the greatest percent error of each shape. Okay, so now we're doing that percent error. Remember, percent error, when we're setting that up, it is the greatest difference, and so when I'm talking about greatest difference, I'm talking about the minimum or maximum measurement, and we're dividing by the measured value. And so they give us the measured value here, 127 feet and 211 feet. So the first step we're going to end up having to do here is find out what the perimeter is. So the perimeter equals double, or let's do it this way, 127 plus 211, and then I'll double that answer. And so when I do that, that ends up giving me 676 feet. Okay, so that's that. That's the perimeter. That's the measured value. But then there's some error that can go along with it. So let's find out that error. So 127 could either be 126.5, because I think they're rounding to the nearest whole unit right here, to the nearest whole unit. So 126.5, or it could be 127.5. And the 211 could have been a 210.5, or it could have been a 211.5. So what we need to do is find the perimeter at each of those levels. The smallest level, the 126.5. So we'll add that to the smaller one of the other dimension, 110.5, and we'll double that number. And so when we do that, we ended up with a 274, or 674. And when I take a look at the larger one, it would be 127.5 plus, and then I'd have 211.5. And then I have to double that number. And let's see what that is. I don't have that one in front of me. So 127.5 plus 211.5. Get that number and then double that. I get 678. And so either one, they're both the greatest difference. Well, the difference, when I try to find that, greatest difference is whichever one is further away from the measured value. So 678 minus 676, or it's going to be 676 minus 674. Well, they're both the same number in this case. They both equal 2. So the greatest difference is the same. So it's just 2 over the measured value, 676. And so we go ahead and do that division on the calculator. And so 2 divided by 676 equals, and it looks like 0.0029. Okay, so 0.0029. So we're going to round this to the nearest percent. So you see how that 9 is going to end up rounding this up to 0.003. Changing it to a percent, well, leaves us with 0.3%. So that's the amount of error that would take place there. So same thing for the area, except now we're just using area rather than perimeter. So area formula would just be 14 times 11. And so we go ahead and multiply 14 times 11, and that gives me 154. So that's the inches squared. So this is my measured value. Now I find out the area of the minimum area. So 13.5 to 14.5. That's my range for 14. For 11, it's between 10.5 and 11.5. So I find the area, so 13.5 multiplied by 10.5. And when I do that work, 13.5 times by 10.5 gives me 141, and that was 0.75. Well, for the area for the maximum was, there it is, 14.5 multiplied by 11.5. And when I go ahead and plug those numbers in, 14.5 times by 11.5, and that gives me 166.75. So I find out what the greatest difference is. So you got to do subtraction. So it's a little bit of work here. 166.75 minus 154. I'm going to find out what that is, and then I'm going to do 154 minus 141.75. find out which one's further from 0. So when I do that, I've got that number minus 154 gives me 12.75. And when I take a look at the next one, I do 154 minus 141.75, and that gives me 12.25. And yes, 0.25. And so I see this is the greatest difference, so I'm going to take that number and divide it by the measured value, 154. So we take this number of 12.75 divided by 154, and there it is, 0.08 and then 27. So we go ahead and move that decimal over 2 spaces. The 2 is not big enough to round that up, so we say that's about 8% error. Well, those are the types of problems you'll see on the assignment. Good luck.